So, Mission Привет. Как дела? Okay, don't worry. I'm gonna switch to English. So, thank you very much for the invitation to talk here today. My name is Рафаэль Мараньон. I'm a founder and CEO of Wavyn, a startup building software for autonomous vehicle. And today we want to talk about trends in Autotech. So before jumping into Autotech, I would like, first of all, just to go through the agenda for the evening and also tell you a little bit about myself. So I think we have like this event is, for my understanding, is 2 hours. So we break it out like a first part and then a break and then a second part. And I think there is a Q&A in every part. Is that what you guys normally do every other week? Is that the format?
Yeah,
Okay. So let's try to figure it out, but that's kind of how I break down the talk. So you're wondering why I'm here today. So there are 2 good reasons. The first one, St. Petersburg is the hometown of my wife. So as you can see in the picture, we are very attached to this beautiful city. Okay. The second reason is just I meet wonderful people here in St. Petersburg, a great community of engineers, and they welcome me, and they were okay talking to me in English, so beautifully. So that's I meet them in the IT GM, and that was really a great opportunity for me to meet engineers here in St. Petersburg. So about myself. So I've been a product manager for the last 12 years, in both in Europe and the US. I've been working in Amazon and also in Cisco in Silicon Valley. I've been working also in Spain. And well, this is one of the products that have been launching recently. I've been launching in my career product internationally to millions of customers. So this is the latest one. As you can see here is the Amazon Fire TV, which is a streaming media player that connected to the back of your TV, let you watch thousands of movies on 4K and ultra high definition. This device also brings with the remote control and also include the Amazon voice assistant called Alexa that let you actually search via voice for thousands of movies, changing channels, and also let you even turn off the light of your house. So this is Amazon Fire TV. As you can see here at Amazon, we didn't shave until we ship. So before Amazon, I was also in Silicon Valley working for Cisco. I was building switches and router, and also I had the opportunity to create an initiative actually in our 2,000 engineers organization to make our company operating system ready for the Internet of Things. So that was a lot of fun. We create, actually, this picture is from our team built a model of a train from Deutsche Bahn, remember, and to demonstrate in Cisco Live San Francisco in 2014 to demonstrate how the Internet of Things actually improved the passenger experience. So that was at Cisco. Before Cisco, I went to MIT to do my master in business and engineering. And I had the opportunity. In 2010 was the boom of social media. Social media were reaching masses. And I founded a club about the MIT Social Media Club to discuss actually how social media impact organizations, university. This club make a link between researchers, entrepreneurs, and we create a very beautiful ecosystem at MIT in Boston. So this is one of the classes actually I created about social media at that time, and I was also teaching at MIT. And now I decided recently to quit my job at Amazon and found a company. So this is Wavyn. We are building, it's a startup. We build software for autonomous vehicle. We are in still yet. And we have a team located in San Francisco, Seville in Spain, and now St. Petersburg. We focus on computer vision. We focus on actually on mobile apps and also on better hardware. So if any of you has expertise on those topics, please talk to me after this talk. We are growing, so we look forward to engage other folks, talented. And now let's talk about a little bit about Autotech. And this is the problem that actually Wavyn, not only Wavyn, but the industry of Autotech is trying to solve. So let's start with the problem. And the problem is very obvious. I think everybody in this room, they know, right? This is 3,000, more than 3,000 deaths every day on road crashes. This is still crazy. And it's decreasing. It's decreasing because there are a lot of improvement. But still, it doesn't make sense at all. 3,000. And the worst thing is that for ages from 15 to 29, it's actually the leading cause of death. So this is the worst epidemic that we have nowadays. So this is the problem that self-driving cars and auto-tech companies and startups, we're trying to solve. So let me ask you first, how many of you work in artificial intelligence? Any of you? A little bit, right? You're working on that? Okay. How many of you have been researching before or kind of interested on self-driving cars? Okay, okay. So we have some folks already. So I think there is a lot of going on here with the self-driving car, and I've been working in the entertainment industry, building devices so people can watch movies every night, which is wonderful. People love it. We use other social networks just to communicate with friends. But this is very I'm very passionate about this kind of problem because it's actually using our engineering skill in order to make an impact and saving life. I think is something wonderful. So what's have been done so far already on this? There are three things. First of all, infrastructure. For the last decades, I think there is a huge improvement. Only the highway, all the type of median barriers, the marked lines, all traffic lighting systems, they all have improved enormously the safety of the road. So that is something. Actually, it keeps innovating. Now they call it the traffic calming. Is kind of all those design of the physical roads in neighborhoods that they design in a way that the car cannot speed it up. So I think this is something that is doing a lot of progress. But this is on the highway. What about in the car? What about the safety in the car? So in safety in the car, there are two approaches. One of them is what they call the passive and the active. The active is actually preventing the accident before that happens. Passive is actually mitigating the crash after that happened. And the more popular one for passive is the airbag, right? So airbags, seat belt, after you crash, you want to save the life of the passenger and minimize the injuries, right? So but still, you don't prevent the accident itself. The active is actually more interesting because it helps you to actually not to get into the crash. So you don't drive more death, but you minimize the number of collisions, which is incurring a lot of expenses, right? So, and the more popular here, it's already like 40 years old, the anti-lock brake system, the ABS, but it's already 40 years old. I think 40 years old when Steve Jobs launched the Apple II computer. So I think 12 years before there were any internet users. So this is the technology that is very popular in the car industry, and it's still popular 4 years later. So this is something to think about it. However, we have emerging solutions for the active safety of the vehicle, and those are becoming very popular. The semi-autonomous vehicle, or some people call it the advanced driving assistance systems, and also actually the full autonomous vehicle. Who knows what is the difference between both of them? Anybody? Yeah, are you familiar with the ADAS?
Because there's still driver in
Okay, you have a virtual driver. Okay, but how many of you knew about this before, about the ADAS? Just want to check a little bit. Okay, how many? Okay, that's good. So I think this is good. And so the ADAS It's what probably, let's say, Tesla Autopilot can be categorized, classified as ADAS because you still need the driver on the car. So the ADAS is all those technologies that help the driver with the driving process, braking, accelerating, steering the wheel, those kind of monitoring, detecting, those kind of technology, but still the system is not able to drive all the way by itself. So this is the kind of how they classify those systems. And this is very interesting type of conversation when we talk about trend, because there is a discussion about which one should be first, right? Everybody understands that, okay, you start with the technologies, and then later you just go to a full autonomous car, right? That's the way that I understand. We need to start actually putting on practice those technology that let me brake the car, accelerating. But there is some people actually in this transitioning that they don't see this is the way it is. Let's take a quick look. The car industry is changing, it's transitioning into more software-driven type of technologies, right? This is no ABS anymore. We are talking about high computing, making calculation with the different sensors. So, and we are talking about the life of a person is at stake. We are letting a computer, actually a robot, to control our life. So this is a lot of software going on, and as you know, as an engineer and developers, you know that the software is different type of culture in the companies and so on. So it's not anymore about the car itself or the manufacturing. We're talking about software culture, and in software company culture, we like more kind of innovating. We like fast life cycle. We like actually we're taking more risk so far. However, in the car industry, I don't think those type of risk are not acceptable, especially with the billion of cars on the road, and passengers and cyclists. So what's happening here is that we have two types of company today that they need to talk to each other in order to achieve their self-driving car kind of goals. We have, in one side, on top, you can see the traditional car manufacturers, okay? And in red, you can see the tech players, okay? It doesn't say the names, but I believe, I think, do we have a pointer? Yeah. So the first one, I believe, is Toyota. I think the second one is Honda. And the first one here is Google, Apple. This is maybe Google. And this is Baidu, okay? So you can see here how there are many more tech players, the car manufacturers. And also you can see here how in car manufacturer, most of the employees are non-software. In tech company, most of them are engineers, software engineers. So if you really want to do this revolution and this transition, and you need the more talented engineers, where do you think that most talented engineers want to go? To a company where there are a few software engineers? I think everybody wants to go where there is a bunch of them, right? So this is probably one of the challenges for OEMs. They don't count with the type of talent that they need. So this is shifting in some way, kind of the way this industry is going to be set up in the future. For example, before, car manufacturer and suppliers, they organize themselves in verticals. However, the tech industry is organized more horizontally. And you can see, for example, how mobile phone is organized. We have a kind of two operating systems, Google and Apple, in some way. So here, what we can see in the future, and very soon, actually, is how the suppliers, the car manufacturers, the tech players, they're gonna be all together. There are a few more OEMs like Tesla and some Chinese company doing also, like I think NIO is one of them. So, and then we have a new player with the mobility, car sharing. So this is how the model is changing for verticalized kind of industry, where they have the full control, the car manufacturer have the full control of the stack, and now it's more horizontal when a few tech players, they're going to build horizontal infrastructure. The reason for that is because people want to have all their applications, all the kind of data consistently across devices and places. When you start watching a movie in your car, then when you go to home, you like to your movie keep playing on your home. So the only way to have this seamless kind of experience is by having the same operating system. We see in the phone today. We start seeing on the TV. In the smart TV world today, we have a few players like a streaming media player, Apple, Amazon Fire TV, Roku, and they're all trying to get into every TV in the house. So you have a similar experience. So similar is going to happen here probably. We're going to have some of those companies in your car, in your living room, in your bedroom, in your mobile phone, and all of them are going to give you a similar experience. So this is expected once the software become the key part of the car. So in other words, the car is going to become a mobile phone on wheels. Similar to what's happening in other industry where internet disrupted the banking industry, some of the 20 years ago with the internet or 10 years ago with the mobile phone. So we can expect similar things on the car. Any questions so far? We're going to have a Q&A at the end, in the middle of the session, but feel free if you have any question. Okay. So before I was talking about semi-autonomous and a full autonomous kind of approach to solve this problem of reducing or increasing the safety on the road in the vehicle. And what is the difference? Why we don't go full, why we don't go semi and then we go full. So there is different approach. One of them is from Google. In Waymo, actually this is the CEO of Waymo, and he said basically that ADAS is not a good idea at all. And they base these thoughts on their data. They have been running with the autonomous vehicle for a while already, and they realized actually that people, when they were in the car and the car was driving itself, they were actually not doing anything at all. They were getting distracted. And this is very dangerous because the car is not supposed to be on full autonomous. It's only assisted. So the driver needs to be engaged, so when needed, they can take care of the vehicle. And this is kind of a perception of, there's a perception what people would do when they have a semi-autonomous vehicle. When the car actually keeping the vehicle between lines, is braking, is accelerating on a traffic jam, and it's doing almost everything, but you need to be engaged. You need to be ready to take over the steering wheel. So some of the research say that this is people actually will get distracted and they will do other things, and when the car is needed to take care, they will be out of context, so they won't be able to control the car. This is what some of the research they are saying, which is very, very scary, right? So the more comfortable people feel with the technology, the more they trust, and the more they trust, the more relaxed, and this is what is not acceptable, at least for Waymo. Let me quickly show you what people will do in a semi-autonomous vehicle. So what do you think about it? Is that true? You think it will do all the things? When the car is actually driving by itself, even though it's only semi-autonomous. We know that we need to take control sometimes. Will you put your life on risk by doing those things? We have seen worse things out there, right? So this is kind of the discussion. It's a great discussion. But also, let me tell you about the second approach. The second approach is this one. Okay. First of all, this is kind of the graphic, how people get distracted today in cars. What is the cause of death? And we can see there's 8% of distracted driving. So drowsy driving is getting much better. People don't fall asleep anymore in their car. Okay, this is still a problem. They're wearing the seat belt, and the alcohol is getting better, speeding too. But distracted driving is increasing. Now we use our phones and other technology, distracting technology, which is a big problem, because if we introduce technology to solve the problem of death on road, and now people get more distracted and they die more, so we're not solving any problem, we are making it worse, right? It's counterintuitive. So that is something that is under discussion right now. And Google is one opinion. But then we have another opinion here. There is a research that was done by MIT, and this is a group of researchers and students, and they decide actually to validate that hypothesis. Is a semi-autonomous vehicle actually disengaging the drivers so they can get into accidents? So they ran actually more than 300,000 miles with 25 cars, most of them Volvo. I think they use also in Tesla S and Tesla X. So they were driving in different roads around Boston. And after doing this test, which is huge, this is huge, almost 300,000 miles is a lot. So this is the conclusion that they got. So first of all, people love it. Autopilot from Tesla is really awesome. They love it. It's just, if you are in a traffic jam, you just use it so you are more comfortable. If you are in a highway, in any road that is possible to use, people really like it. And the more that they use, the more comfortable and the more they use. So I think was 30% of the miles and 20% of the hours. So the adoption of the autopilot, a semi-autonomous technology, was very, very good. A very, 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 very high usage. One of the conclusions that they got is that the driver, they are paying attention. They are engaged with the driving. They are not doing any other things that we have seen before. They are paying attention and any type of road, in different type of roads. So this is one of the insight from the research that validate that people really, the human robot, the human machine kind of interaction was good. The driver let the car to drive on their own, but then later when the car need the driver to correct or to do an intervention, the driver is ready to take the wheel. So this combination, this integration is working. Some of the conclusion is that they use but don't trust, which is great. Is that the way it should be? And also the drivers are learning from the limitation. And this is even more interesting because one of the main problems, and we will talk about that later, about adoption of the self-driving car, is about the don't trusting on the algorithm, because I don't understand how they're making the decision. It's like a black box, the artificial intelligence behind it. However, if you see how your car is driving and you see the limitation, you build this communication between the machine and the human, and this is a good cooperation to solve the driving problem and increase the safety. So,
sorry, what is a glance profile?
Which one?
What does it mean? Glance profile, physical engagement.
So the glance profile is what the user are doing inside of the car. So what kind of they were expecting, depending on the highways, more boring. They're gonna do different type of distraction. They have camera connected inside of the car, looking to the eyes of the driver and to the. So it's kind of the.
Attention.
Yeah, they initial hypotheses were thinking that, oh, maybe in a highway the distraction is higher, people can fall asleep, while in a small road people are freaking out about what the car is going to do. But the profile was similar in some way in both contexts, and that's what's one of the big part of the research. They were engaged in the driving in both contexts, in a boring context, in more active, more dangerous context. So one of the things is that, okay, so it's not so bad. Semi-autonomous driving cars are not as bad as we expected, because that would be a problem, right? If we don't, from manual car directly jumping into full autonomous car, like this is the Waymo approach, may be very, very hard to do it. Very, very hard to trust one system suddenly, because we know in technology adoption is key. In order to get the masses. So if we don't do it slowly, it's not going to happen ever. So this is great news, and this is, I think Tesla already have on the road 300,000 cars with autopilot, and they are running, I think, 1 billion miles already, which is compared with the 2 million miles from Tesla. Is I think semi-autonomous car that use ADA. I think is a great opportunity. This is a report from McKinsey, and they say that the adoption of the semi-autonomous of the ADAS, they expect it to increase, and the main reason is regulatory, forward collision warning, that I will talk later about that feature, and some lane warning departure. They will be obligatory in the US and Europe by 2020. The customer love the features, the safety, the convenience. They like it, and the whole industry is going after what the value is, and the value is very clear according to this report. The value for the new type of car in Autotech industry, I think there are 3 or 4. First of all, is the electrification. They want electric car. This is what the customer want. They want a semi-autonomous or full autonomous car. And also they also want the opportunity to increase connectivity. They want to, in other words, they want to watch movies in the car. They want to do more connected things. This is all that telemetry. Having more infotainment in the car is something that they are looking for. And also the customer also see a lot of value on the car sharing. All those kind of innovation, they love it. Not having to own a car. I think this is one of the things that they're looking for. So semi-autonomous and a full autonomous car is something that is going to increase, and semi-autonomous is going to start earlier. OEM and supplier, they love those kind of features because they make a differentiation with others competitors, and this is an opportunity for a startup, for example, like us, that we can create different value. Being software still allows us to get into the industry easily. It's true that we cannot get into the intervention of the car, right? That's require a lot of certification, a lot of testing that a startup doesn't have that capability. You can do a mobile app for something else, and you can publish on the App Store, and everybody is using tomorrow. You cannot do this with the car. But now I will explain some of the startups that actually are doing this for all cars as well. There is some of the features that can be used for legacy because they don't have intervention. I'll talk about that a little bit later. So this is about how we transitioning from previous technology, the previous solution that helped to reduce the number of deaths on the road, and how the software is gonna help here. So what are the investment? What are the opportunity? Let me ask you, how many of you are actually have your own company or building your own projects? Any entrepreneur or want to be entrepreneur or something? Yeah, one? Any more? Okay, so there's a lot of money on the table now for self-driving car. This is great news. They are investing heavily in a few areas. You can see here, auto cybersecurity, V2V communications, fleet telematic, driving safety tool, and of course the semi-autonomous and autonomous vehicle. This is an area that is being invested. Just to see some numbers, last year there was a little bit more than $4 billion on startups. Okay, we're talking about investment on private company. Private company, mainly startups. It doesn't include all the big investment that the tech giants are doing. This is not including the. It's not including the probably I think I don't know the 1.6 billion for the Mobileye. It doesn't include the GM and SoftBank that they have 3 billion. The couple of billion that Google Waymo. So it doesn't include those. But it includes, for example, the one for NIO. NIO is the Chinese company who is trying to build a new low-cost Tesla. They have office in Silicon Valley as well. So this is kind of the investment that is happening right now. To give you a sense of how those investments are going across different other trending technology, any of you are working on blockchain? One, okay. Okay, so what about fintech? Who is working in fintech here? Yeah, what is the more popular kind of industry that you guys, can anybody suggest? What is the? Web. What type of web?
Mobile maybe.
Mobile?
Mobile.
For what use case? What kind of, which industry? Is it banking? No, right? Is what kind of use case? Telecommunication, okay. So yeah, I was trying to figure out if somebody is working on trendy. Okay, so you can see the blockchain. They got, I think it's a little bit more than $500 million. The whole artificial intelligence in 2016 was $5 billion. So I think much of this is in here as well, because in Autotech there is a lot of going on artificial intelligence, as we will see later. So this is just to have an idea how the investors are putting money, are kind of enabling those startups to create those technology and value. So this is how Autotech is shared by country, and we still have the US, even though they have been decreasing. I think it was 78 the year before. So there are other players who are taking part of it. Second one is Canada, and then Israel have a lot of artificial intelligence startups playing a very good role. Like Mobileye is one of the biggest ones. That was acquired by Intel. And then if we classify by different other regions, we can see that in California, in Silicon Valley, there is a lot of investments on this area. So this is a focus for very hot focus. This is what I know, where I come from. Now my friends is working on this. So, but
sorry, is it about investors or about startups?
Startups being invested. Yeah. So this is where the startups are located. The startups that have been invested. The $4 billion, how this is being distributed across the different startups.
Okay, you need to help.
Well, it doesn't matter where you build your startup, but the point is that if you are in an ecosystem, so probably where they are the investor, you have more chances. Investors want to be closer to the startups. But just give a sense of the. This is still right. It's trending right now. And this is a few of the startups. You can see here a few of them. I think this is live from 2016. So some of them actually they are not in the market anymore. I see here, I think NAFD, they were doing like a heads-up display. Is the projector that you put on the dashboard of your car. So it's giving you speed and other kind of signal on the dashboard. I think there is a Pearl. Is a few Apple employees who build a camera, the rear camera. Many cars don't have the rear camera yet. So, and they build like an accessory that you put in the back of your camera, on your car, and with your phone, you can see the back of your car. So the only problem I think was more, I think $500. So I think they're out of the, I think they finished the project. I think so. So there are other interesting one here, like for example, the Nauto they got 150 million. They have a camera actually that they tracking the eyes of the driver, so they see how you're tired, and this is great for fleet managers. If you have 100 or 1,000 of truck drivers across the country, you want to know how they're doing, right, for their safety and also for the brand of the company and for the people they are on the road, right? So, I mean, any in particular, I know that, I don't know, any particular that you guys know? That would be great if any of you.
You know, this bright box remote.
Which one?
You see it under the connected car section.
Yeah, which one is it?
The remote.
Yeah, you know that?
Yeah.
Do you mind to tell us a little bit about that?
Hello. So my name is Sergey. I'm from the former company, the plant near the St. Petersburg, in the Vsevolozhsk, and we had some project with the Bright Box company, and we implemented the module to the CAN bus and the application to run the vehicle from the phone, you know, and check the sensors of the vehicle, so we know well this company.
Okay, so what type of vehicle? Is that a commercial or private vehicle?
The private one.
It's a private vehicle. And when you say control from the mobile device, what type of control is that? Is it like monitoring, or is that
start the engine,
start the engine,
close and open the doors.
Okay, interesting.
And check the voltage of the battery and those sensors.
Interesting. And so your team is doing what part of the what part is your team doing? You mentioned what part?
What do you mean, what part?
Yeah, what part of the development?
They're just controlling the project from the car manufacturer.
Okay. Yeah, very interesting. Thank you very much for sharing. Yeah. Any other that? Yeah, I'm sure that, I mean, this is very new for the last few years, but probably as soon as those startups grow, I think there will be probably collaboration from many other. So yeah, let me show you one more here, just to show a few of them. So Autonomy is an MIT spin-off of a student, and they build, I think they built the first robotaxi in Singapore. Also, we Drive is built by Stanford artificial intelligence professors, I believe. And we don't know much what they are doing yet. They are in a sealed mode. Then the other words and the Comma AI, they are very similar. They are building very interesting, both of them, because they are building developer kits, I think hardware and software, to retrofit all cars. So the Comma AI, I have seen a few videos, and they are able to connect their system to a Prius car, Toyota Prius, and they control a car. So in some way they are hacking the car. So which is a lot of thinking around that, because we are assuming that this is very hard to do in a new car with all the regulation and everything. Imagine that people can buy something and put it in your own car, and you have a self-driving car. It's a high promise, but interesting for thinking and at least for see how far they can go. Remember that there are 1 billion cars on the road today that they don't have anything at all. So I think any single feature that is safety to use, provide high value, and reduce the number of accidents and death. I think this is really, really awesome. Okay, so I think this is what for the first part. I mean, I think we have a break now. I believe so. For the so and I just want to follow why you normally doing this. Can you, Sergey?
Yeah, sure. We have tea. We have some snacks there. Let's have a break. And
so you want to do normally you do the QA now and then another one later. How do you?
As we would like.
I'm happy to take a few questions now.
Yeah. Any questions, guys?
Yeah, let's do a few questions and then we can have the break and then continue with the second part.
Hello, my name is Andrei. Is there some possibility for self-driving car logic sometimes to break the rules? For example, with system of prevention, car accident prevention. Because sometimes, for example, for me, there was a case on a highway when I've seen that a car in front of me decided just to turn right. And on the left, there was a straight line. So for self-driving car, it's impossible to cross these lines. So if it's something in front of the car, it will stop the car. But if nothing is on the left and the car in front of me, it was just 1 meter to left the line and to make it clear. So I just, I was on the driving wheel, I've turned the left signal, I've decided to turn left, and the car stopped immediately, and it was horrible. Because if on those moments some in the car will be with a tea or coffee or something, yeah, it will be.
Okay, so it kind of is a question related to will an autonomous car follow the rules of the road or behave like a human
possibility,
and break the rule in order to avoid the accident, right? Is that the question?
Yeah.
So the answer is yes, of course. It will break the rule and try to, because the outcome is to minimize the number of accidents and the impact of the accident. And we're going to talk later about that. I have more coming up and explaining exactly what is those decisions are made. So I think that later I will talk about the answer is yes.
Okay, thank you.
Any other question?
Привет, my name is Igor. I have two questions. The first one is quite small. Is there any solution that help drivers from falling asleep during the driving process for highways or somewhere?
Okay, so for falling asleep, I don't know any of them. I only know the water on the neck. It's only that one somewhere. But I don't. There is nothing. There's some vibration in the seats. There is some kind of alerts. But I think for drowsy driving, I don't think there is that I know. And probably there are applications, there are people working on that. But this is maybe an opportunity for some.
You don't need to worry about falling to sleep if you have an autonomous car.
Yes, but now I do worry.
Yeah, but yes, that would be one of the in the semi-autonomous. That will be one of the included features. So, yeah, I think.
And what about my old car?
Yeah. So this is a great opportunity and business opportunity for startups. So how do you make a driver actually to be alert when you're driving? So the Nauto camera is tracking your eyes. Yeah. So I believe. I don't know the feature that they have on, but I'm sure that they have something like that. And this is for the monitoring your conditions. They actually, the software that some company are using is actually detecting your humor, your reaction, your emotional reaction, if you are aggressive that day, and are able to give you warnings. And some of them is not only about visual or audio warnings. They may have something connected to your seats or the wheel that do some vibration. So I think there must be something already in the market to solve that problem, I'm sure.
Of course they are, because my uncle, he is driving for locomotives, the trains, and there is a very old Soviet system which just alerts us with this period, and if he doesn't press button, the whole train will stop.
Okay, so
this is system.
It's pulling every 10 seconds or 1 minute to see the driver is.
Once in 15 minutes maybe.
Yeah,
I don't remember exactly.
Yeah.
And the second question is about the Russian maybe specific problem. There is sometimes on the roads we have wrong signs or incorrect marks, and the autonomous car must somehow to deal with it. So what maybe this the same problem or the other problem will be in another country. So it's maybe a challenge for it.
Okay, yeah, this is a great question. I think it's very related to the other one. How the car, and this is what actually a good self-driving car need to do, is actually act as a human and be able to see all the options and minimize, respond as a human. This is the full self-driving car. Probably in a semi-autonomous car, they will hand off the control to the driver, so the driver make that decision. But in a full autonomous car, because all the decisions are based on data, and the data probably show that these cars cannot follow the landmark because it's wrong and can lead to an accident. I think those are kind of a few of the dilemmas that the machine need to solve based on data. I don't know if in the future the machine itself can report somewhere that its landmark is wrong. So that is another discussion where what's happened with the machine actually can automate those feedback that today we don't do. We just ignore the robot and we do what we have to do. So this is a interesting area.
Thank you.
Okay. So now we're going to talk about something more fun. So we're going to talk about the technologies and the use cases. I think like everybody who want to get an introduction on the self-driving car, they want to know, okay, what problem? I know that the problem that you are solving, but how look like? What is the experience as a driver, right? Because the good news of this is that everybody is a potential user of those technology, okay? And this is fun, right? So we understand that. So technologies, okay. So the best part of the self-driving car and why now is actually very hot topic is because we have more computing right now than ever before, and the high computing and better sensors as well, like a lower cost for the sensors. And this combination of high computing together with the more accessible sensors plus convolutional network or neural network that we used to have before is nothing new, but now they get adapted to the new level of computing and sensors is what actually make everything look very good. And now is when the industry say, okay, now is when we can do an autonomous car, and not before. Now is the time now it's feasible. And the regulators and the government are ready for that. There are 26 states in the US that allow a company to put their self-driving car on the road. And there are a few of them, I believe 2 of them, Arizona is one of them, that you don't need to have a control driver. A control driver is a person who is anyway there, if something happens, take control. It's just this person is already out. So it's fully autonomous and there's nobody in the seat. So this is happening. Those are some of the technology of the hardware, the sensor that they are using. The radar, the LiDAR, and the camera are the basic one. Ultrasound is also helpful for parking and other type of usage, pedestrians, so short distance. So how many of you know about the LiDAR? Okay, it's quite popular already. Okay, So just to give you very quickly, so the radar is the one who reaches higher distance, but using radio waves. So that make not very good on resolutions, but he get high range. Then the LiDAR is the best one because combine both the lighting, which measure the distance, and also the LiDAR is able to map the scene based on waves by sound wave. So they both, and it's also moving around, so it's capturing the 360 degrees. So LiDAR in some ways is better than camera because camera is a sensor, it's only getting the lights. The LiDAR is sending with the laser, is sending the beam, so then it's reflected. So as you can imagine, you can use LiDAR in a bad weather condition and it will work. However, for something like a line detection or objects, the LiDAR is not working well. It's very good on high range resolution, but it's not very well on the picture itself. So camera beat LiDAR on that way. However, in the evening, at night, or with bad weather, the light conditions are not good. So because it's only a sensor, it doesn't emit any light, so it doesn't have the proper reflection. So this is a high level. Every single sensor is used for a particular purpose, but normally what's happening is that they mix it. They do data fusion. So they use different sources to compensate one to another. I'm not going to go deeper on the hardware side. There is a lot of resources online where you can check what everyone is doing, how they do data fusion, what is the more proper for one use case for another. What I did is actually do a comparison. This is what the industry is discussing more, is trending now. That's why the part that I will explain a little bit. How is the discussion going on? What are the different voices? So we have on top the LiDAR kind of vision, and then the camera. You know, mobile eye, I've been doing some camera on the dash cam that you can put in the windshield of your car and can detect the road and give you some alert or warnings. So then we have the popular, I think this is the Velodyne 64 because the LiDAR is working on number of beams that you can have, and this has 64 beams at the same time. There is one new with 128, which is the best one. I think this is $80,000, and there is one with 16th that the punk, and I think this is 4,000. Still very expensive for a startup to buy because you need 3 as a minimum. It's still expensive, but it's getting better. 4,000 for a LiDAR. The only complaint is that some people believe that for the 16th is not enough. The resolution is not enough. So, but you can see the two options. So in terms of the discussion here, there is two opinions. And you can see Elon Musk, the CEO of Tesla, saying that, hey, in Tesla with the camera, we are able to achieve the full autonomous vehicle, which is the opposite that the industry was saying before. I believe Tesla is using 8 cameras in the car today, but they believe that they can achieve full autonomous only with the cameras. And you can see here some kind of comparison based on a few parameters. In detecting the lines, the camera is the only one who can do that. And also traffic lights and traffic sign is the only camera, is the only one, they only have the property to differentiate color. The LiDAR, because it's a laser, is only gray color in the infrared. They're working in the infrared, so this is what you saw before. So a camera is also is a low cost. It's very cheap. For $8 you can have a camera for your car. So, and then the radar is the one who, I don't think the radar is much. I don't know how the cost of the radar, but it's working very well in combination to the others. This is the other version, and the source is Quant Energy. It's one of the startups that was in the other slide, and they're doing lower cost lidar. I think they are competing with Velodyne, which is one of the biggest one, and Velodyne is the one that Google Waymo cars are using. And you can see here what they say. They say that an autonomous car needs to be working 100% of the time, and if the light conditions are not good, you cannot stop the car. So that's why lidar is the only solution for that. So, and when you look at the different parameters, you can see how lidar beat most of the bad weather conditions and some of the hardest situations. The hardest situations while driving is what makes challenging the autonomous car. 90% of the time the car is driving on the road, you know the rules, anything happen. But there is a 10% of time where you have situation and weather condition where this is where the model is not working well and you need a higher performance.
But still they cannot check the lines.
They cannot check the lines. You still, with the lidar, even though you pay $80,000, you need to buy an $8 camera to do data fusion, which is okay. So camera is great, right? For startups, it's great. It's cheap. You can buy a lot of them. And also, if you are very good on software, so it's even better because now you have a software, the high computing that you can get for AWS or Google Cloud to train your models. And now with an inexpensive camera, you can have a system working. At least you can detect the lines. You can detect the car in front of you, which is great, and it's great for startups. You don't need to be a Google and invest $1 billion on your company. Now anybody in this room can actually start experimenting with this tomorrow, okay? And you can see here how the computer vision is doing a few activities. First of all, when you see a picture, you do image classification. You see, what is this? This is a bike, this is a car, this is a pedestrian, okay? Then what you do is the location or detection. It's actually where in this picture is it's actually the bike, but the bike is there, and I put a bounding box, okay? And then after you do the classification, you know what is this, and you know where is this, then you can do some segmentation as well, okay?
What software is it?
Which one?
What software? Which software it is?
So this is any type of computer vision software you can find. I mean, we'll talk now about different tools that you can use, but this is they're using different framework for that, different tooling. I can show you now. I don't know which one is this, but this is not hard with convolutional network, and you can get this very easily today. They are open source online, and you can do this tonight at home. There are a few tutorials, there are a few courses on Coursera. There's one in MIT as well, that are online. So you can do this tonight if you want at home. It's really cool.
How much time does it take for a computer to detect all objects?
Okay, so good question. So one thing is training the model, and the model take a lot of time, can take even a week, but then the detection is instantly, okay? The detection, once the model is trained, the detection is just is less than 1 second. It's very quickly. And you will see now, I'm going to show you a video, but you will see how far it is. Okay, so we talk about classification, we talk about detection or location, and also segmentation. The segmentation is actually identifying each pixel, every single pixel. So you do the whole car, and you put a label related to the object. Okay?
Can I ask a question?
Yep.
Which type has more priorities, from the inside or from the outside of the autonomous car? So if there is something, if there is something terrible going to happen, what autonomous car will do? You know, hit the wall and will kill passengers, or hit people from the outside the car, walkers.
Okay. So this is a great question, and we're gonna play a little bit with the game that we have here. Maybe we can do together. And yes, I have an answer for that. This is the self-driving car dilemma, ethics dilemma, and we're gonna talk about this. This is a good question. So we talk about sensor, more computing capacity, and now deep learning. This is what you use. You use deep learning to solve that problem. Why you use this deep learning? So if you're gonna put your life on the hand of a computer, of a robot, you really need to make sure what you're doing. So it's good that we got the question about, hey, what about in those cases? Because the car is supposed to drive according to the rules, right? Well, we are not programming a car, a robot, for that purpose, who's gonna save my life or gonna kill me the way that we program other applications, right? We're not gonna do either waterfall, or we're not gonna do a coding every single use case like we do today. We need to use actually artificial intelligence where they are based on large amount of data, or real data, real world data. We need to train the algorithm so to think as a person, and the only way to think as a person is to train the algorithm with a large amount of data from real use cases. And the good news is that we have the computer capacity today, and we have artificial networks that exist for many years, but now they come together. And this is a case where here you can see it's a perception control. You just program what the car should be doing. We know the rule of the road, we know the different situation, and we program everything. However, this is the, 10% or less of the cases where this is human communication. It's when you really get in a big chaotic traffic jam, and the only communication here to solve this problem is using the communication between the drivers, like putting the hand or this, like going different way. This is a human communication. So if you want to really make a very good autonomous car, you need to do both. You need to do this, but then you need to cover the use cases where you need some kind of human communication. How do you do that with a computer, right? In a full autonomous car. So we are using deep learning. Deep learning is the methods that help you to manage a large amount of data in order to get some understanding. So this is what we use. And let me show you how that falls into the inside of the whole artificial intelligence classification. So I think everybody of you know about machine learning, right? We heard about that more today. Deep learning is a representational learning or feature learning, because it's learning for the feature of the picture, what you see in the image. And this is a good example. This is the entry of the neural network, and this is different layers, and this is the output on top. So based on the color of the pixel, we're going to determine if this is a car, a person, or an animal. And all this layer in representational learning, they use a different part of it, like the edge, the corners, and the object part of the. So it's very straightforward. And there's a few tools that you're asking about, the different tools that you can implement today, deep learning, and this is some of them. I think everybody. How many of you know at least one of these? I think everybody, right? No? You use this for other purpose rather than for artificial intelligence?
No, I'm the heard of it.
Okay. So who know more than two? Okay, which one?
I know everyone.
You know all of them?
Yeah.
You're working with all of them?
Yeah.
So can you tell us a little bit about your use case? Why do you use those?
It's used for neural networks for different tasks.
Okay.
Generative models, so creation, compression, segmentation.
Any particular use case that you want to mention?
Stop.
I use it for some basic stuff like image classification, and there was a project with generative models for music.
Okay.
We used LSTMs and all of that stuff. And we use different libraries to test which one is better for certain tasks. That's all.
Okay. Any preference? Can you?
We work mostly with Keras with TensorFlow underneath.
Okay. Okay.
That's
Somebody else? Thank you very much. I appreciate you. Anybody mentioned that is also known some of them? Okay. So let me put you. Actually, this is a video that I mentioned you before. So this is using YOLO, which is another. So the detection is pretty fast. It's I mean, you can put this to work at home. I've done myself, and this is very straightforward. There is a lot of available framework that you can use and model, already trained model. So it's very it's much easier than before. So now let's go to the feature, to the use cases. Probably this is easily to see. So there are two types of features that I classify this just to mention a little bit of which one can be applied to all cars or new cars. But there are some of them that doesn't require intervention because they are based mainly on monitoring and alerts. So you don't need to actually touch the brake or the steering wheel. While the intervention is those one who you need to make an action. And the driver expects you to make the car to make an action based on what they learn, instant action. So yeah, I will go one by one. So the forward collision one. By the way, how many of you know a few of them already have been using? Which one?
Collision avoidance, emergency brakes. I've used some of my previous questions was that I was in a situation when the system was activated.
So is this in your car?
It was in the rented car. It was my own.
Okay. You remember what car was that?
Yeah, Toyota CHR.
Okay, Toyota CHR. And they have this feature, right?
Yeah.
Do you try yourself or you were in the passenger?
Yeah, by myself.
How was the experience?
It wasn't good.
No?
Yeah, because when the system was activated, I just hands-on on this safety roll.
So what the experience wasn't good? You kind of you didn't trust the system.
It wasn't actually an incident. It wasn't possibility of incident. So it was false positive.
All false positive.
Yeah.
Are we talking about the collision avoidance?
Yeah.
So can you explain what false positive mean in that context? You were going behind a car and try to.
It was only on the road. It was 30 or 40 centimeters of another car, which completed turn right, and then the system decided to stop in prevention. But it was like 10 meters before the car.
Okay.
And
so how do you avoid this kind of? Do you take control of the steering wheel and the?
Yeah.
So you easily override the decision of the car,
Yeah.
of the feature.
Yeah.
That was not difficult. It was okay. So let me explain you a little bit about what is the situation. Normally, the car using those radar and camera, of course, most of those features that this is today in some of the car, they are not using LiDAR. They're using on just a camera and radar, some ultrasound, and they are detecting where the cars are around, and they make a decision based on the situation. If the car is getting very close, they detect, they alarm the driver, hey, the car in front of you is very close. However, and the car actually can touch the brake. If this is the feature include the control of the brake, they will do it. The nice thing of this feature is like they let you know what's going on. For example, when they move the steering wheel, they do a little bit, so you can move around easily and override the decision. So you interrupt what the car is doing. The car is trying to help you, but it's not easy for you to remove that option in real time. For example, forward collision alert you when the car in front of you is getting very close. And there are some startups that are using cameras only just to see how far they are. The car itself, when they use a car manufacturer, they use probably 2 cameras to have the stereoscopic vision, so you measure the distance, and also they complement as well with the radar to improve the data, and they alert you with that. This is for the forward collision warning. This is what kind of accident prevent this. This is the rear end collision. It's very common. 40% of the crashes are rear end collision. That somebody is not paying attention or is getting distracted. The car in front of you will stop suddenly, and you just crash that car. So, and there's some studies that say that with this technology, they can solve with up to 23%. So this is a lot. From 2.5 million, only in the US, 23% can be resolved just with a single camera and a beep. Mm-hmm. Okay, so potentially this is huge. Probably for a car manufacturer, it may be complicated because the user experience can be similar to that we just heard about it. And a car manufacturer is doing a car that lasts for 11 years, so as an average. So they make sure that they prefer not to launch it rather than launch it and working. However, we believe in a software improvement, and software OTA, you can improve every day, right? This is the way that software developers are working, and that can be easily improved. So that's why having a camera or even a cell phone who look to the road and see the car and give you an alert in a naturally way with a wonderful driving experience can be a solution. This is another same one, but it's actually do the intervention. This one is activate the brake. Okay, so when you're getting very close, it sends, it do the alarm, but at the same time, it's slowing down the vehicle. Some of them they precharge the brake, so it saves like a half second. The brake is ready for a sudden stop, and some of them brake is stopping the vehicle completely. Okay, in that case, you can see here it's not 23%, it's 39%. So this is much more effective. So only the alert is not enough. Doing the whole job is important too. This is another one, which is I think this is the one that you mentioned before, right? So in that case, the vehicle is going to steer around the obstacle, which is more challenging. Now the software and the hardware actually need to do the calculations, need to see what are the options to sort it out, to what is the best corridor possible on the left, on the right, and make a decision on time to avoid the obstacle. I believe there must be a rear camera as well, because if you want to get into this line, you need to make sure that nobody is coming here. So there is some nuance that need to be solved as well. But this is another example of how the detection of the car and the intervention on the engine and on the steering wheel can. Yeah, this is another one, line departure warning, and this is the one that is going to help you not to get out of your line. There are three. These accidents are very bad. There are three types of. Let me see. The run off the road, okay, and this is the one that you get out of the road. The head on. This is the worst. This is when you crash a car coming in the opposite sense. And this is the worst. I mean, if you look in YouTube, some of the videos of this one, they are terrible because you just sum the two speed, and they are terrible. And this is just by slightly changing your line a little bit. If you are sleeping, fall asleep for a couple of seconds, you can run into the other line. So this is the worst. They are deaf, I think, in each one of them probably. And then the side wipe, I think, is the one that is go out of the road. So that's one. What they do, the way that works is like every time that you cross the line without activating the signaling, the car assumes that you just are doing this unintentionally. So they will emit a visual and sound alert telling you, hey, it's like the band that you find on the line with the band. I don't know how, the stripes one, the one that make noise. We saw that before. So this is a similar one by using computer vision, using a camera. So okay, so this is only the alert. That alert can be done as well with a phone, with a camera. You don't need to work with manufacturer to do this. The line keeping assistance is going to the next level, and when you get out of the line, it's going to help you to come back. And you can come back in two ways. You can come back by braking on some of the wheels, activate the brake, or just by steering a little bit the steering wheel. Okay, so you come back to your line. And this is actually, the experience for the driver are not very good on this. We'll comment some statistics later, but this one, sometimes driver forget to put the signaling, and if you forget to put the signaling and you are passing some car, the car is going to attract you to come back. But you don't have a problem because as soon as you hit a little bit, not very strong, but a little bit, the system will override the decision of the car so you can pass somebody. So the car understands that you are in control and you don't agree that this is a line departure. It's an unintentional line departure. Okay? So.
I have a question. In which case car recognize a situation when it should work and when it shouldn't?
Okay, so that's the tricky part. If you
Sometimes the driver wants to turn off the road and it's cross the line.
Yeah, so there are some. I've seen a few features there. When you cross the continuous line, they don't let you. When you discontinue, they let you. There are, depending how those are programmed. But the way to know that you don't want to cross the line is because you didn't activate the signaling. If you are in a line and you abandon the line, it means that you should have activated the signaling, right? This is the only way to abandon the line. Are you talking about getting out of the road or some kind of? Tell me a case where you step on the line with unintentionally. No, with intention and without signaling. What case is that?
I mean, cases when the system organizes so, if it should work automatically or not, because sometimes there are situations when the driver wants to turn right, for example, and cross the line, but the system is activated and it won't let the driver to do it, for example. But for example, in our country, many people don't use signals.
Okay, wait. So you're saying that you want to change line without signaling?
Yeah.
And you expect the car? Okay. No, it's no. You should.
Not possible.
It's not possible. You should signal. I mean, you should signal. If you're going to change a line, you should signal. You should communicate with the rest of the road what you're going to do. So otherwise, if you are not signaling when you change a line, I think you probably turn off that feature easily. So this is the only way that I don't know if there are other technology that can look to your face and see what you intend, but I think the signaling is pretty straightforward. I think those use cases where you don't signal and you should, the problem is not the car or the technology, or the problem is the driver that. Okay, the technology tries to help you. So I think that answer your question.
Maybe because there are some situations when you have no time, for example.
Which one? Tell me one.
Cases when you
Okay.
just milliseconds to
Okay. I understand you now. So you say some cases where you need to do it, but I think in those cases you are full of the control of the car, and I think the intelligence, the technology doesn't matter, because and the technology help you to the technology let you to do whatever you want. They could put a little bit harder, a little bit, because they will think that you should keep in the line, but you can override easily. So it's very sensitive. So you can.
The system feels the force of.
Yeah. It's very light force. It's not like hey, the car is keeping me here, but I'm gonna. No, it's just they help you a little bit like steering the wheel, but not enough for you quickly. So it's designed on that purpose, because most probably there are many situations that the camera is not registering. Okay. So this is other easier one, the speed limit. That's also, you don't need intervention of the car. It's just when you're speeding, you just get a beep. Probably it's not very popular. This is an interesting one. This is it's included in the car, so car manufacturer implemented, and you can set up the speed limit that you want to drive. So in that case, even though if you want to go faster, because you already set the limit in one particular speed, the car will throttle you down. So you can step on the gas, but it's not going to go faster. Okay. Even in this case, it's a behavioral changes. One day you set the speed in 120 because this is the way that you want to drive. But then one day you just speeding, and the car starts slowing down. However, let's say that you need to speed because you want to avoid a collision or something, right? Sometimes you need to speed. If you hit the gas harder, you will speed. So you override the decision. So those features are very well designed for those cases. So the human have more control than the machine. The machine assists to the driver, but the driver is the one with the control. So they are very well designed for that. And this is another one with the speed, but also is the adaptive cruise control. It's a cruise control that I think most of us already have. It's very popular, but it avoid the annoying of the car in front of me going different speed, and that's what make the cruise control not very well adopted, because at the end of the day you need to be accelerating and braking with your hand, which is very annoying. But this is very good, because if the car in front of me goes faster, I can go faster. If the car slows down, I go slow down. So the point is that I keep the distance, because this is the purpose. Keeping the safe distance is what we really want. So the car accelerating and the car slow down depending on the distance with the car in front of us. There are other features. I won't get into the details of those, but they are very popular as well on the parking lot, and some other, like for example, this is the blind spot monitoring. This is one of the more popular ones that people really wanted, because this is a common mistake, ignoring the blind spot, and those cause a lot of crashes. The rear cross traffic alerts when we are getting out of the parking lot. Those are the camera who tell you if somebody or a car or a cyclist is coming around. So you can get out of the parking lot probably faster with that, without doing many visual checks. And then the park assist. With the park assist, help you to parallel parking. They don't help you completely. They help you with the measurements, monitoring the area. But I think and in this one, you are in control of the brake and also the shift and gears. So you are completely in charge of the brake, of the gas, and the gear. So they only tell you when you need to turn around and things like that. You are responsible. There are some of them that you can actually get out of the car and the car path itself. I think this is the park distance control. I think this is more useful. You just get out in the restaurant and the car find a spot and park. But I think I haven't seen those yet. Okay, surrounding view.
Rafa, actually, Volkswagen parks automatically, but you need to stay nearby and press the button that everything is okay and you are doing good. And when it does something wrong, you put your finger off and it stops.
Okay.
So, but it does it.
That's cool. Yeah. I think this is I mean, many accidents, maybe not the one that cause death, but many accidents happen on the parking lot, and I mean, this is the more common. And I think that's improved the driver experience because this is running into those costs. And insurance company probably are very, very interested in those features as well. Okay. So now we talk about the feature. This is the last part, and I think it's about adoption, right? So what's happening with the app? Are we fast enough with the self-driving car? Are we going the right piece? Is the technology ready for that? So let me show you what people think about self-driving cars. So 70% of the US driver, they say that they are afraid. They're afraid.
It's okay.
It's okay?
Yes.
So everybody agree with 75%? How many of you are afraid? Yeah, why not?
Because they were accidents.
Don't be shy. Who is afraid of getting into autonomous car tomorrow? No?
If I still can control it.
Okay. So now we are here. You're afraid. You're not afraid when it's perfect, right? When everybody already is 100%. But today you are afraid. Yeah. So we don't trust. It's not proof yet, right? We don't know anybody who have been running for 1,000 miles already. Okay. Sorry, you have a question, right?
No.
Oh yeah.
I just told that Tesla over decades with accidents with this.
Okay. Yeah. There's a couple of. Yeah, we talk about a couple of these accidents, how that impacts the adoption. Very good. So psychological is the more difficult part. People believe more on themselves than on a robot, because it's your life. It's not it's not something that, it's not your TV, your cell phone. It's your life. So you are letting a robot decide about your life. There's a video of a Tesla. And the person recorded and they posted on Twitter, say, Tesla tried to kill me today. This is what the person say on Twitter. My Tesla car, autopilot, tried to kill me today because it was a car was coming and he started moving lines or steering. So the person have to control the car. Okay, so psychological changes for adoption is very important. Then we have experience. And experience is about, hey, the beeping is bothering me, I deactivate a feature. There's a lot of work to do there. And that's why when I say, well, I was commenting about car companies and tech company, I think tech company have been doing a lot of software, a great customer experience, on user experience, and that can be brought to the car industry so they can do app OTA quickly, improve, do usability study, because it can be improved overnight, every week. However, car manufacturer, I believe they change their platform every 5 years. A software company, they do in 2 years. A car company do release every 2 years. Software company, they do every 3 months. They do a new version, so different piece.
I just want to mention that now it's possible to overcome this experience with annoying beeps for a lot of cars it's possible just to turn it off and the steering wheel will vibrate instead of beeps. So when you drive and other people in car are sleeping as usual, so they will not annoy them, but you will feel the steering wheel vibration if you're trying to cross the line or limit the speed or something like this.
Okay.
And I think it's very cool.
I think that probably they're improving. Yeah, I heard about the wheel vibration is one of them. The seat vibration is another one, the seat. And now that makes sense. This is the family is sleeping in the middle of the night, you don't want beeps. And also somebody told me that in some countries, the beep is reserved for something that externally, some car beeping, and this is a threat. This is what you use in order to understand how is the communication. In India, for example, car beeping all the time. So it's like you really need to listen. Your vision is more with the listening, where the beeping coming, so you can actually manage to go through. So the beep is for the user experience designers. I think it's challenging, and there's a lot of work to be done here. This is a great opportunity. And then about cost. So I think I have somewhere there, only 5% of the cars includes the line departure warning as a standard, which means that 95% have to pay for it. I don't know how much is it, maybe $1,000, $1,500, or $200 or $2,000, but probably you don't want to pay $2,000 for a feature that you don't know if you like or you're gonna use. Mostly because people deactivate, turn off the line departure warning. So I think this is not a good model for people getting used of the technology and actually adopting self-driving car or highly automated technology. People need to try, like when you download an app, you try for free. If you like, then you pay premium or something else. But people need to try and get comfortable in order to adopt it. In the car industry, whatever you buy, you adopt it because you're gonna have for 11 years. That model in some way need to change. And that's why technology companies and manufacturing companies need to talk, need to work together on this. I don't know how, but they have to. So how we can transition smoothly? So I don't know, this is, I propose three ways to transition. One of them is overcoming psychological challenges, and this very, very nice article about this. There's a research, and they mentioned that the three challenges, one of them is a psychological challenge, the driverless car ethical dilemma, and this is what we were talking. If I'm in a car and I have two options, or I kill pedestrians, or I turn and I hit the wall and I kill myself. What the car should be doing? Nobody wants to buy a car that's going to kill you, right? So who is going to program that car? And how is it going to be? So that's this free dilemma. And we're going to see a little bit more about that now. The second one is overreaction for accidents, right? And we know the Uber car accident, and we know the Tesla, right? The whole press. There was an article in the New York Times. Fatality in self-driving car forced Tesla to confront his limit. It was a very hard article. But you know what? I haven't seen an article like this saying airbag kill a passenger. You remember that? I don't know how old they are, airbags. And seatbelt kill a passenger. Have you seen an article from New York Times say the seatbelt killed the passenger? Everybody now that a seatbelt and an airbag can kill passenger, of course. But overall, they save lives. We know that without seatbelt, you can get out of the window in an accident and save your life. I have seen myself on the road in an accident. The person get out of the car, save his life. But how many times those people without seatbelt, they die? More times, it's statistically. That's why the car manufacturer and safety engineers, they design this. We need to look to the overall and absolute risk rather than relative risk. And the press, like in any emerging technology, they just want to highlight what is the bad side of that technology. But I think in that case, we need to be carefully with the communications. So for that one, open communication on the algorithm improvement at help to communicate with the users, I think is important. And they're going to be accident. That's why I say it's going to be accident, of course. And I think this is important. And also it's a lack of transparency, because this is a black box. Artificial intelligence, when you work with artificial intelligence and those models, it's very hard to understand it. It's not like you can go to the code, oh, I was trying this, we're doing some testing, it didn't work, let me go and fix it. It's very hard to fix those things on working with the artificial intelligence, because those models are based on a large amount of data. So you cannot change it, you cannot reprogram. You can do something, but actually whatever you are doing, you are inserting artificial kind of programming, so it's going to impact in the whole model. Now you have another black box every time that you change something or introduce a new data, because the decisions are made based on the input that you are putting it and the output. So people don't understand that model, and this is challenging. So the way to solve this kind of psychological challenge is changing people's mental model. How do I change the model of a person who think that the car in that moment need to go to the right? So the only way is by understanding the limits of the technology. That's why having a semi-autonomous car at the beginning is helpful, because you have a little bit of control, right? So you can experiment with that. What you said before about, hey, what about in that case that I don't signaling? You can play with the feature. You don't signal, and you see how many times the car is learning from you. If the feature is using artificial intelligence, if you do this often, eventually the car will understand that you don't signaling often, and you should. And the car probably, in some cases, they won't let you do that. They won't change the direction. So because it's learning from your behavior. So I think exploring the feature and learning, I think we created trust, and we understand how the machine is making the decision, and hopefully adoption will increase in that sense. So let's go to the first one, because I think this is one of the more, I think that everybody loves this case. This is from the Moral Machine at MIT. This is a cool website that you can visit. And they put you like a game, that's 10 or 15 questions. I mean, we can play here all together, but I think it's going to take a long time probably. But let me comment on this. So what do you guys, let's take a look for 30 seconds, and then let's vote. You guys can read, or it's okay? Okay, so simple. So you have here 2 girls, 1 boy, and 1 woman. And here you have 1 elderly man, 2 elderly women, and 1 woman. The traffic light is green, which means they are doing the right thing. They are not breaking the rules. And now this person have 2 options. Or go, and let's say that the car, they have a failure and the brake is broken, okay? They have this situation. And this is an autonomous car. And you are the designer of this car, of this system. So there are only 2 options. Or kill the pedestrians, or bump with the wall and kill the passenger. Who say that this is the option number 1? Who believe in option number 1? Okay, so you save the passengers, right? Because you buy a car that don't kill yourself, right? Okay. What about option number 2? Who? Oh no, this is sorry. Option number 1 is this one. Who will save the passenger? No, who will save the person?
Kill the passenger.
Sorry about that. I got confused. So option number 1. Who will kill the passengers? 1, 2, 3, 4. 4 people will kill the passenger, right?
1 passenger
No. 4 or, yeah, you say 4 or you kill 4.
Depends on where I am.
Yeah. Okay, and the first one, you see the death, you kill those people. In the second one, you kill those. Okay, so we have 4 or 5 people that we kill the passenger. The rest, I'm assuming that they will kill the pedestrian, right?
Actually, I believe that the choice of passenger is survive more than pedestrian.
Oh, because the car have a car safety, right? Basic safety.
Actually, I have third option.
Which one?
I think we can save everybody by breaking via right wall. If you
Which one?
scratch wall by the car, that
This one?
Yeah, right.
I don't think you can break this one.
Why not?
Oh, because this is a separator and those are designed so you can.
Okay. I'll start to scratch this thing with the side of a car to stop it instead of braking.
Yeah, you will try in some way. Okay.
Yeah, and actually this is more effective because those people go right, so I will be more to their backs and their possibility that they went away.
Okay, but those are the algorithms to consider the option. But let's say, for example, that you know for sure what's going to happen because the distance, the speed that you're going, and everything, the calculation is like, or you kill 4 or kill 4. So it's like a killing. So killing the passenger, that makes more sense, right? What about if those people are actually, they are kids here? You change your vote? If we have kids here, what would you do? Same thing.
The same.
So why would you kill the passengers of the car? I mean, I'm trying to understand. This is very interesting discussion because I did myself the test. I invite you to do it.
Let me explain. I just choose the first choice because
the car driving is dangerous, and the people who is in car, they are responsible for this accident. So if only 2 cases, the first one is correct. So they should be killed.
Yeah, actually I have some addition, and that when they drive in a car and sit in the car, they should have some kind of insurance that they use this car, and if they the company manufacturer of the car vehicle will take care of their funerals at least.
But you know, any car have a liability insurance. It will pay also for the pedestrian that you kill.
Well, but they have insurance, but not those people. You don't know.
No, the insurance, any car insurance have. I think the insurance from 3 parties are mandatory. The insurance for you is it may be optional. So I think the insurance of the car manufacturer will pay for the. I mean, this is the way the insurance works. Anyway, so we have a dilemma. I mean, somebody can reply to this. Why the fact that you buy a car that can kill people, you need to be losing. Who's going to buy a car that will kill you?
Yeah. I also want to mention, as you show several slides ago. So if we will just in this car kill car owners, next day New York Times will publish that Tesla killed Tesla killed the driver, and if this car will kill pedestrians, New York Times at the end of the some news column will publish that some driver killed on the road cross or on the road accident some people, and that's all. So for the manufacturer, the best options it's not to kill the driver.
Yeah, there is. I completely agree. The question is very complicated. That's why it's a dilemma, and you have a many perspectives from the car manufacturer, from the user, from the press. It's very hard. Any options is a bad option. So actually, some of the questions were very easy. Some of the questions they put like a bunch of dots here, And the question is, do you save the dogs? Actually, let me show you my results, just for your reference. I was surprised about some of the results, even for myself, but I recommend you to go online. You can go and do yourself and can compare with mine. But I was surprised. For example, this is very obvious. So I protect humans against pets. So even though the traffic light was green and the dog had the right to cross, in that case, I killed the dog. Because I think a person, but some people may think differently. So, and they have a different age. If you will kill a baby or an older person. There is another one. Okay, you will kill a large person or a fit person, or somebody, or a doctor or a bank robber. You know, it's a lot of fun. So you question.
So you would kill younger than older, right?
Okay, let me see mine. No. I will save. Okay, yeah, avoiding. Oh, wait a second. I think, yeah, more saver. I think yes. I will kill older. This is my preference. I'm kind of like the average. So, yeah. So the intervention. Some people think that if you're breaking the rule, you need to die because you're breaking the rule, right? Some people think no. You just somebody make a mistake, cross the red line, and you're killing them. So there is all a dilemma. So depending on the person, here is passengers of the car or pedestrians. Here is more people or less people. And woman or man. I think I'm more willing to kill woman than men. I don't know why. But this is the result. Okay? So very interesting, but you can see here how there is a dilemma in this area. Okay, so secondly, the way to improve adoption is actually I'm an advocate for improving the adoption by starting with simple problem to solve, and I think semi-autonomous is a good solution. We understand the Google approach or the Google hypothesis that people get comfortable with technology, they will relax, and there will be more accident. So technology introduces more distraction. Well, if you do well the driver experience, you don't have problem. The driver will be engaged and will get the technology to help them to improve, not to get worse. And that's if we design well. That's why I believe this is, and actually there's data already that's saying that the forward collision warning and the line keep assistant is improving 40%. So this is good already. So this is the semi-autonomous, and this is the full automation already. So I think this is important. And also for software and startups, there is an opportunity also to bring this to cars. The average of every car is today 11 years. So we have billion cars that's going to be for 11 years without any technology. Somebody needs to solve those problems. And I'm coming from an industry where we have been doing my previous product when I was working at Amazon was a streaming media player. Do you guys know the streaming media players? The stick that you put on your TV and your old TV become new with a new interface? It's like the stick. So this is helpful because if you can put something to your car and making it smarter, that's not only it helping you during the 11 years before you renovating your car, but also it's gonna get you familiar with the technology for a low price. By the time that your car is 11 years and you're gonna change, you already have 11 years of experience with technology that help you with warnings when you depart line, when you take the car in front of you. Those are very helpful. And you get familiar, you like them, so when you're gonna buy a car next time, you're gonna buy a car with those features. So I think low cost of the technology, early testing, and getting familiar with that, I think that will help. Well, I believe the advanced driver assistance software and systems is helpful. And the last one is about experience. It's all about experience. If the experience of the driver is not enjoyable and they feel safety, what we are doing doesn't make sense. So we need to make it easy for them to adopt and something that makes completely sense. And this is a study where they say that 66% of the drivers who buy a car with this technology, with the lane, with the lane departure warning, they disable, they turn off. Probably because what you just say. The reason can be because the technology is not good enough, maybe, and there is a lot of false positive, maybe. The reason may be because it's beeping too much when the kids are sleeping, maybe. The reason can be probably because I don't like to be judged by the technology. Can be many reasons why you, or maybe just because it's not because it's not working well, it's because you don't like the way that it's beeping. Maybe there is another way, or the vibration is better. So I think the engineers and the designers need to work on this, and they need to make more agile kind of feature where you can get data from the user and improve it, rather than some engineers in a car company designing and doing during 5 years is what it takes to design a car, and then shipping during 5 more years, and the feature is going to be like that for 11 years. That's the wrong approach. What we should be doing is a feature that you can change overnight, that you collect data from the user for the adoption, and then you improve like your mobile apps. They learn from your behavior, and you can personalize. Every person is different and should be able to have the feature in a different way. I think this is why technology and software companies and startups can help this industry to get adopted by doing more agile type of feature design. So this is some statistics as well about how customer likes the line departure warning. And look at this. The warning itself, only the warning, no intervention of the car, which is easy. You can put it with a camera. You don't need to manufacture. It's 12%. People like it, you know. And the line keeping assistant is 7%. So what's happening is actually people don't like the machine take control of the direction of the wheel, of the brake. People want to have the warning, but they want to keep the control. So this is a very interesting piece of data. So this is some of the brands that they are doing very well, and some of them they are not doing very well. So, but people, the one that is not doing very well, still, people are 59% are satisfied, which is, I think, is good a starting point for those technology. Not everybody's happy, but half of them they feel like it's useful, right? So we know that some of the brand actually they're doing better. So it's about design. It's not about technology and limitation. So we can do much better. It's promising. And you have some of what people like. It's good for me, but it's critical for my husband who frequently drifts. I don't have to point it out now. So look at this one. The LKA will work for a few minutes and then it forgets what it's supposed to be doing unless your car drifts out of the line, mostly toward the shoulder. This is what you mentioned before, right? Is it doing wrong? Okay, so you have some data. We need more of this. That's normal. In a design feature, that's normal. But we cannot wait the cycle of a car manufacturer. We need to do faster. And I think software developer, like many of you, can help here. So you're welcome to help. So
actually, it depends. In Russia, we usually haven't roads. We have directions.
Okay. Yeah, this is another interesting part, and I think deep learning helps that, because if we try to design feature for following the rules, it's not going to work because there is always 1% of the time where things are not according to the rule. So if you say that some countries probably they have all their tolerance of driving behavior and more based on human communication, deep learning can help with that because it gets real data, a large amount of data, and the good news in Russia I've seen a lot of dashcam, so there's a lot of data being collected. So I think mobile apps, so dashcam or dashcam with those feature is something very very interesting, and I think this is something that is all about collecting data, and this is a good approach. You can get some of the limits and some of the more challenging programming questions. So in conclusion, I would like some takeaway. So just to close the talk today, I don't want to get more time, but basically the semi-autonomous with a year or 2 years ago was like challenging for many people to accept. is being proved by Tesla and by some study in MIT that is good, and for adoption is great. Changing the mental model of the people is needed, no problem. Always with every technology, internet, mobile, always is the same. It's difficult to change our mental model and trust on technology, but if we do it slowly, with using hybrid model, we will all see the benefits of it. So I think this is we need to try the technology in order to start thinking if we feel comfortable. And the last one is making enjoyable for the driver and making the car a place where we can be safe and we can have a great driving experience. So I think as developers and people in technology, I think it's a great opportunity to work on these problems. So my question is, are you up to the challenge to start tonight getting some detection at home and do some work? I think this is very interesting. I highly recommend you the MIT online course. This is a very good one. I have some reference and some slides that are, so this is it's a free course that you can take, and there is a lot of good content there. Okay, and now I think we'll answer some questions.
Yeah, let's do some questions. There is a situation when you're approaching a zebra cross and car to the right stops, and there may be a human who wants to cross the road and you don't see him. So is there such system that detects these situations and slows you down?
Okay, so you say that there are a pedestrian crossing the street?
Yes, and you don't see a person, you don't see a human, but you see a zebra cross, and it is possible for human to be out of your vision, but on the road.
Okay, so and you are in control of the car, right?
Yes.
We're not talking about full autonomous car.
Yes, but you don't know there is a human or there is not, but a car, I think, should somehow alert that
there is a crossing there. It may be somebody crossing.
Yes, maybe.
So, okay, this is more like an infrastructure vehicle communication type of thing, where the infrastructure means that the road is telling to the driver there is a crossing, and it may be. Is this kind of the type of communication that you are referring? I'm trying to understand what is the question.
I mean.
Such system already exists. For example, BMW, you have night vision, and so this system detects temperature of every object.
Okay.
So it can detect our human temperature and tell.
Yeah, but I think the question is the question is should the road communicate to the driver that there is a.
If the human is out of vision of different, for example, lidar systems, this system can detect it.
Yeah, actually, this is was the accident from Uber. The driver was in a autonomous, so and the lidar who have detected that person, but I think that was not activated. But that's actually the case where a human can avoid this accident, but an autonomous car can't do it because the lidar can see more than the person.
Yeah, actually, if one car stops before the zebra crossing, you must stop as well according to rules. So it's really in the rules. You must stop, and so if autonomous some autonomous car made according to rules, it will stop. No matter is there actually a human or not, you must stop if other cars stops before zebra crossing.
Yeah, but in the case that because this is what the rules are not being respected, right? In so many cases, this is a case where there is a lot of accident. So could the technology help in that case? So I don't know if the lidar can detect the person behind the car, but this is where the technology can help the human to solve.
Let's suppose the situation, there's two self-driving cars and they happen accident. Who is responsible for the consequences?
Okay, good question. So, well, now we have more data, right? Probably it's like when you have a dash cam, the discussion is over, right? You just it's a matter of analyzing the video and see who is at fault. I think in those cases, I can imagine that probably one of them will use the wrong data. That's a good question. Or there is some cases where an accident, something happened, an animal crossed on the road, and now this car is going to the different line because the car detects the animal and thinks there's a person, and turn on the left. The car has seen probably the car has seen the other car.
But decision may be hidden in inside AI, and we cannot detect what
look at, no, but when you say that about the data, it's not the decision. The decision, it doesn't matter. What's matter is the facts. Yes. What's happening? What's happening is that this car hit the another one, and they hit the another one because this car went to the other line. It's like a. I think the problem is similar to the one that we have today. The difference is that now we have a computer we can open the black box.
Okay, we can find the responsible for, but who pay for the
one who, according to the rules today, the one who was the fault.
So it is a manufacturer.
What?
Manufacturer. Who make this car, because nobody drive.
In an autonomous car, the insurance is by the manufacturer probably. Or I don't know how they will work together, but yeah, it's a car, the car insurance. Yeah. Another thing is that the manufacturer probably has to pay if there is something wrong in the decision made. But if the decision was correctly made, and there were no other solution.
So the judgment for the.
Yeah, I think it's a very interesting question. I will thought about that because there are three components. First of all, is what's happening at that moment. The car maybe be doing the best option possible, right? But if an animal crosses on the road, it's an accident. Secondly, this is the first thing. It was an accident based on maybe the person the owner of the animal is the responsible. I don't know. Anyway, the second decision is based on this accident that the animal came. Is the algorithm did the right decision or did the wrong decision? This is the manufacturer.
Gracias, Rafael, for your presentation. And my question is out of this scope. I'm like to know your vision about vehicle-to-vehicle and vehicle-to-infrastructure communication. I'm working in a company who implement mission-critical point-to-point communication, and so we thinking about another direction, like implementing vehicle-to-infrastructure for emergency systems.
Okay, so this is a very good question. Yeah, I didn't cover in this presentation anything about vehicle-to-vehicle or vehicle-to-infrastructure type of communication, but I think this is an area that is very relevant for the cars. First of all, my opinion is that vehicle-to-vehicle and vehicle-to-infrastructure require a lot of standards between the different entities, companies, government, and those kind of conversations to determine the protocols are very long conversations. I've been working for more than 3 years at Cisco, and it's all about standards and standardization, and there's a lot of conversation. It takes long years, many years to get there. The approach from the industry today is like every single player is doing everything on their own in an independent format where you can do progress on your own. The advantage of this is that you can go faster, and then you increase security. Because if the infrastructure is giving you signal, and those signals are not correct, you may run into an accident. However, if you as an entity, as a car, you have everything, all the vision that you have as a human, you have now with camera and with other sensors, you can make the decision based on that. So in some way, if I will design the road and driving from the scratch, imagine that we don't have driving experience for the last 100 years since the car came up, and we want to design this system from the scratch. Of course, I will design the road before the car, so everything works, right? But before we come from a legacy system, that design need to be made based on the car first. And this is the right approach that the industry is using. They are using the car first and simulating the human being. So the car, the technology is simulating a human being. So not much changes. If you need to tell to the user that traffic light in a particular country managed by an IT department is actually sending the signal to a car who is going to avoid a crash, that would be scary, because I can buy a car to Google or to Tesla, but buying a car that depends on an infrastructure managed, I think this can be much more segmented and probably very long journey. So for the government to approve, and actually it's more expensive. Infrastructure is very expensive, and we can see that, for example, with the telecommunication infrastructures. Now mobile is more agile. So to answer your question about what I think about infrastructure to vehicle and vehicle to vehicle, I think it's important to do it, and I think we'll follow on the vehicle initiative or independently achieving the first milestone. When the car are driving by themselves, if there is a communication between vehicle, some kind of common protocol to talk to each other, it's going to be great for data fusion. So I have a LiDAR, I have a sensor, I have a camera, and then later I have a signal coming from the traffic light and also from the road. That would be great because I have everything. And as a machine, like as a human, I will trust some signal more than others and make a decision. I think that would be the right approach, following the human model and making it autonomous. That answer your question, kind of?
Yeah, thanks. Let's do the last one.
Yeah, my comment is also additional to your discussions, that I think most all of these problems will be solved in 10 years because they're pretty temporary until we will have enough amount of self-driving cars on the road. When we will have a lot of self-driving cars and only small amounts not self-driving cars, they will communicate. And the same communication now we have in the ocean between the ships. When they see other ships on some distance, for example 10 miles or 15 miles, they start discussion on some protocols and they decide the way how they will cross like the roads, because they also have some kind of roads, recommended ways, and they need to communicate how to cross it. So we have something what we could do on the basics and then adopt it to the cars. And I think it will be solved like in 10 years, but it doesn't mean that now we don't have a problem, so just wait. So yeah, we also need to solve this and step by step increase amount of self-driving cars on the roads. And the more self-driving cars will be on the road, the more safety will be, exactly, because they will communicate. And with roads, with other cars, it doesn't matter, but this communication.
Yeah, the amount of data is key on this. On the perfection of those algorithms. It's about miles. But remember this data that I provided before. Google have been doing this for already from 2009, and they already have, I believe, if I'm not wrong, 2 million of miles of L4 self-driving. So, however, Tesla, in a few years, they have 1 billion. So, look at the trade-off. You prefer 2 million full autonomous, or you prefer 1 billion of semi-autonomous? I think both approaches are important, but I think quantity is going to help us more, and then later more layers. Not only the sensors, But sharing the sensor between companies, there are many initiatives that are putting the data, so every company can actually train their model with more data. And I think we will go to that point where everybody share all the use cases. I think very quickly. I know because in Amazon, in Alexa, for example, the algorithm gets better every day. So I think the more data, the more usage, the more that we learn, and that will help a lot.